Welcome back, my bad army. So, this is the implementation of linear regression. In the previous video, I have already told you what is linear regression, what is simple linear regression, and what is multiple linear regression. Okay, in this video, we will going to implement simple linear regression as well as multiple linear regression. Okay, so without wasting our time, let's jump onto the video. Okay, so first of all, in linear regression, our first thing is simple linear regression. Okay, in this implementation series, we are going to use Google Colab, and you can use Visual Studio Code, PyCharm, Anaconda, anything that you like, or Jupyter Notebook. But we will use Google Colab because it do not require any hardware computational things is like GPUs and powerful CPUs. You can do everything online. It can store you everything on your Google Drive, and it have all the machine learning libraries already installed. So you just have to import it and many more reasons. Okay, so just let jump onto Google Colab. Just you have to open your browser and wait a minute. Yeah, open your browser, search Google Colab, and just rename the name of the library here. I already done it so that we can save our time because time is everything right now for everyone. Okay, here we will need the three libraries. First, NumPy, second, sklearn or scikit-learn, third, sorry, matplotlib. NumPy library is used for mathematical functions. Sklearn library or scikit-learn libraries provide us the machine learning algorithms and other things which we require to implement machine learning algorithms. Okay, we are not going to make the linear regression function by ourselves because these algorithms are already made by someone and we have to just implement it. Okay, so second, our third thing is visualization. For visualization, we are using matplotlib, which will use to implement the graphs. So just import. We are numpy from matplotlib.pyplot. We are using importing plt, and from scikit-learn we are using train test split, which will split our data in testing and training. And one linear regression, of course, we want linear regression model. We are doing linear regression problem. And mean squared error. Mean squared error or MSE is an error we can see that how amount of error our model is giving us. Okay, so let's generate some. Yeah, here are some. We generate some sample data. First, np.random.seed42. Here, what we did is just we set as random seed 42. That means if you are giving something randomly, is like here is np.random 100 comma 1. This will select random values from 100 to 1 to 100. Okay, and multiply it by 2. Okay, but our value of x and y will be same because our random seed is 42. If I set the 24 and you also set the 24, then everyone in the world will have same random values. So this is good for matching the answers. Okay, so here is like we have made x. It will select any random value from 100 to 1 and multiply by 2 and our y or dependent variable. Here I just add 4 in, into the 3 into x and plus np.random random 100 into 1, 100 by 1 means any random digit from 1 to 100 it will plus. Okay, so you can see that I have did some like relation, weird relation. It's up to you, you can make any relation. Okay, and just we will run it and just see our x and y, x comma y. Okay, so this is our x, you can see 5.09, 7, many values of x is like, and this is the values of y. Of course, more than x because we are adding 4, multiplying by 3, and adding some random number. Okay. So after this, what we will do is like we will split our data. Okay. Here we will use 4 variable: x train, x test, y train, and y test. And we will use train test split. We are using 4 variable because this function give back the 4 values. So 4 values will be stored like this. You have to write same like this only. Wait, yeah, like x train, then x test, y train, and y test, because this function give the value in same order. Okay, here in this function we have to give only the x, the y, and then the test size. Here test size is 0.2. Actually I like 0.3. Yeah, test size is 0.3 means 70% will be the training data and the 30% will be the testing data. Okay, so after that we will random state 42 is same as like random seed 42. Okay, so just run this bar and just create the mm, wait, yeah, and this is how simple we can use scikit-learn to make the model equal to linear regression, which we just imported here, and our model is made. You have to do nothing. You just have to import the model. So simple, made by scikit-learn. Okay, and just we will use this model. For using model, we use model, which is this variable, then dot fit, then x train, y train is like training data, that's learn it from here and it will learn it. So like it will take some time. Yeah, so here uh, we our model is have fitted. Now we just make a variable ypred and write model dot predict. Wait a minute. Okay, sorry for the interruption. There was something is like in my laptop is some warning time. Yeah. So ypred, here we made a variable ypred and just write model dot predict. Dot predict function is like it take the fitted model, and here we give the x test and it will give the predictions. Now it will predict something, and to check it we will use this MSC, a mean square error. Okay, and mean square error, yeah, mean square error just tell us that y test and y pred is how different. Y test, which we already have, and y pred, which our model have. The wait, I will print it. Our model already predicted. Yeah, so this is showing that 0.6, which is very means not so good. But let's just plot the graphs to see how our model is doing. Here I have used plot.scatter because we want a scatter graph, and just give the value of x test, y test, and color equal to black. This will make a scatter graph, and on that we will make a line, which is a regression line. So we give just x test and y pred and a blue line, which width is 3. Just we label our x axis and y axis and name it and just see the graph. Okay, so you can see that our regression line is not going so well, which our mean square also telling that 0.6 is the error, which is quite high, and you can see so many points are far from the line. That means that it's not so good. But congratulations, if you did these things with me, you have implemented your first simple linear regression model. Okay, so now to is like it have many flaws. To correct this, we will use other machine learning algorithms, and you can just try to clear the data, or clean the data is like for the simple linear part. But now we will jump on the is like we will just save it, and we will make a new notebook. Why we are using making a new notebook? Because we will go for multiple linear regression. Okay, so just yeah, and just one point to be noted, that we will just plot we can't plot multiple linear regression, because it's a 3D image or 4D image or 5D image, and we can plot only 2D graphs. Okay, so means if you're a math student, you will say that, sir, we can plot the 3D graph as well, but I'm plotting only 2D graphs here. Okay, so first we will import numpy and sklearn things. We are not importing the matplotlib because we are not plotting something, and we will generate the x and y. Here we generate x and y. Okay, but there is a difference in x here. You can see that they are two depend. Okay, wait, capital X. Sorry. Huh, yeah. So you can see that there are two x's, two value of x, one, two, one, two, two dependent variable. Okay. Sorry, two independent variable. Dependent variable will be only one. Okay. And just we skip to the bottom, and we will just copy from the last code and just paste it here. Okay, all are same. It's like same thing, same model, same fitting, and same prediction, same error. Okay, just remove this. We have already done it. So you can see that this error is more than the previous error. Okay, so that means it's performing more poorly than the simple linear regression. So in this video, we are only going to implement the simple and multiple linear regressions problems, and I have taught you how you can make the implementation. They are quite similar. Here just you have to take the more than one x, okay, and everything is same. Just I will give a quick recap again. Just import some library like numpy, sklearn, and matplotlib. Make x and y, or is like import it from kaggle. Check your x and y are in right state. After that, just split in x train and y train. After that, use your model, save your model in an variable, and then fit your model on the training data. After that, predict your model giving the test of x. After that, find out the mean square error or the error of your model. Means you think that which error suits your model most. Okay, then after checking the error, print it. After that, plot a graph. It's like graphical visualization is more accurate. Means you can take 0.6 as a mean square error, but many of you will not find it so informative. But when you will see the graph, you can see that how our line is going and how the points are not covered so far. So you can see that our model is acting very poorly. Means not very poorly. Many points are, is like it's covering one, two, three, four, five points. Is like, quite poorly. So that's all for today's video, and I hope you have liked this video. Just subscribe it, share with your friends. I literally need some subscribers, so please support your joker, subscribe it, and bye bye. Take care. Bye.